Okay, so this is class on February 6th. We're looking at page 251, still talking about radical expressions. We're looking at example 2. We're going to simplify some quotients. So what that means is we have a radical, and underneath the radical, we have a fraction. So part A says, open radical, or square root, x to the 4th over y to the 5th. Okay. So the way we're going to simplify this is the square root of both the numerator and the denominator. So what that means is we can rewrite this as just a fraction. So we have the square root of x to the 4th over the square root of y to the 5th. Okay. Now, there's some rules. So let's start with the numerator. So what is the square root of x to the 4th?
X to the 2nd.
Correct. So now we have a new numerator of x to the 2nd. Now let's look at our denominator. So we have the square root of y to the 5th. Now this isn't an even one. So how many y's can we pull? How many groups of 2y's or y squared can we pull out of y to the 5th? Remember, we had to pull them out of groups of 2.
2 groups?
Let's say that again. 2 groups? Yeah. So we can pull out a y squared, right? Y squared. But we still have one y left underneath the radical sign. So our denominator becomes y squared square root of y. Because that's still is the same thing as the square root of y to the 5th. But there is a rule. When you are simplifying, you cannot leave a radical in the denominator. You cannot leave a radical in the denominator. That's something that's really important to put in your notes. So you can't leave it with the square root on the bottom. So we can actually get rid of it. And the way we get rid of it is we need to do something. We multiply the denominator and the numerator by something to make that square root go away. So what do you guys think? Let's just discuss what could you multiply the numerator and denominator by to get rid of this square root of y?
4.
If we did 4, we'd get 4x squared over 4y squared square root y. Just by the number 4 won't get it, but I see where you're going with this. So now if we have square root of y, what can we do just to get that y out of the square root sign?
Y?
What kind of y?
Y.
What if we multiplied it by another square root of y?
Y squared.
Not y squared. If we do y, so if we do square root of y times square root of y, what happens is we get the square root of y squared, right?
Yeah.
And if we have a square root raised to a square, they basically cancel each other out because they're inverse operations. So then you're left with just a y. So I'm going to pause this video for just a second, and I want you guys to think about it. Yeah. So it does make sense, Robert?
I don't think it does.
Okay. So now let's back up a little bit. So what if you have the square root of x squared? What is the answer for that?
X.
X, right? This is just doing the exact opposite. Now what if you have the square root of x and that is squared?
Just X?
Just x, exactly. So
I think I got it. So we stop the y, but no, it's a root sign with this.
right, because remember when you are multiplying, let's look at it one other way. I'm gonna erase this and make myself some space. Okay, so if I have the square root of y times the square root of y, that is the same thing as the square root of y squared.
Yeah.
Because remember, when you're multiplying radicals, you multiply what's underneath of it and you throw the radical sign on top. So then that's the same thing as y squared, and then you end up with just plain old y. So now let's go back to our original problem we were looking at, x squared over y squared times the square root of y. So what can we multiply our numerator and denominator by to get rid of that square root of y? If we used another square root of y in our example below, could we do the same thing above?
Yeah.
Yes, so let's, and remember, in a fraction, whatever you do to the numerator, you have to do to the denominator. So what it would look like is our numerator becomes x squared times the square root of y all over y squared square root y times the square root of y. But we can't leave it like that either. We have to do some maneuvering. Okay, so I'm going to move some stuff down here. It's kind
Couldn't you just do y to the second, the square root of y to the second, because that's basically what you're saying.
Exactly. So now we have a numerator of x squared square root y over y squared square root of y squared. And can we simplify that? The numerator we cannot. It's just as it is. So it's x squared square root y. So what does our denominator become?
Wouldn't it be y to the fourth?
Not y to the fourth, because remember that when you take the square root of that y squared, the square root and the squared cancel each other out. So you're left with just a
y.
So now our denominator is y squared times y, which is the same thing as
Y to the third.
Y to the third. So now our final simplification is the fraction with a numerator x squared square root y over y to the third, because it follows the rule that we cannot have a square root in the denominator. So we're going to problem that looks like this. So it's square root of 7 over 8y. Okay. So the first thing we need to do is what?
Divide.
Not divide. No, first thing we need to do is remember we're looking at each piece of we've got our numerator and our denominator. And the easiest thing to do is put each one inside of a radical sign. In Braille, that might not be as efficient, but in print it is. So it's up to you if you want to do that. But I think in print it helps a lot. Okay, so now let's look at our numerator and our denominator. Is our numerator, is it an easy number to take the square root of? Square root of 7.
No.
Is it a perfect square?
No.
No, so we're going to leave it just like that.
ESD day students, please come to the east door. ESD day students, please come to the east door.
All right, so now looking at the denominator, is that, again, is that a number, can we take, is there a perfect square of that? Square root of 8y? No, it's not. But we can't leave it like this because we cannot leave a radical in the denominator. So in order to rationalize the denominator, we need to multiply our numerator and denominator by the same thing that will allow us to get out the denominator to not have a radical in it. So, what do you guys think?
Well, if you times the 8 by 2, you'd get 16y, but if you times the 7 by 2, you get 14.
Right, and we don't care what happens in the numerator. It doesn't matter. We're only worried about that denominator. But what we want to do here is actually, let's see. But you said multiply it by 2, right?
Because that would make it 16y, and 16 is the square root.
Nice thinking. So how does this, and then let's look at our y. We need to multiply it by another y in order to get that, that's a square too.
Yeah.
But what would it look like? So would we just multiply it by 2y or the square root of 2y?
Square root of 2y.
Right. It's like basically combining apples to apples. It needs to have that square root so we can combine it. So if we multiply the numerator and the denominator by the square root of 2y, let's see what happens. So our numerator is square root of 7 times the square root of 2y. Our denominator is the square root of 8y times the square root of 2y. Okay.
So that would equal 14.
Square root, remember, you get the
square root of 14y.
Yep.
Over 16y squared.
Over the square root of 16y
squared.
Y squared. Very good. Okay, so everybody kind of see where we got that? It's basically looking at the problem and doing problem solving. It's not a formula. You have to look at it and you have to say
the square root of 16y squared?
Yeah, then we'll take the square root of it, yes.
Oh, wow.
But right now, but this one was a one of just problem solving, critical thinking, and thinking about, okay, how do I manipulate this to make it easy to get rid of the square root in the denominator? Okay, so that is what we did. Yeah.
Question though.
Okay.
With this, is it no longer, is that the correct answer?
Nope.
Since the top y is not y squared, I'm just curious, was that y 14, 16, where they can't be a smaller fraction?
Well, so the 14y is on the numerator, so we just leave it just like that.
I'm just saying that it's 14 and 16.
Oh, the 14 and the 16, reducing them?
Yeah, or not. So
yeah.
People understand, because they're both not the same y?
No, it's not because it's the same y, because we're taking the square root of each of them. Because we're trying to get rid of that square root sign. And if we were to simplify it, we'd be back to exactly where we started.
Okay.
So,
Miss Lowell?
Yes.
Since you can't have the radical sign in the denominator, wouldn't that be just 4y?
That would be 4y.
It would be square root 14y over 4y.
Correct. And that is exactly it. Because we manipulated, we changed, we thought about how can we create something that we can take the square root of in the denominator to be able to get rid of the square root sign. And we did that by multiplying the numerator and the denominator by the square root of 2y, and then the final simplification is the square root of 14y over 4y. And this is a legal answer. So now we're gonna throw in another piece. So we were doing square roots. This time we're gonna do one with a fifth root. So we have, and this is again the example on page 251. So we have the fifth root, which means our index number is 5, and the fraction of 5 over 4a. All right. So I'm going to rewrite mine as the fifth root of 5 over the fifth root of 4a. So again, we don't care what's happening in the numerator.
How would you express that in Braille again?
Do you want to do it as one giant one or as a fifth, or it might be simpler in Nemeth to keep it as under one radical. Otherwise, it's going to be huge.
Okay, so 5.
So your index number is 5. So if you remember, you do so the index of radical indicator, okay, is 126.
Yeah.
Okay, then you put your 5 for your index number. And then you do your AR for your open radical sign. And then you do your fraction, 5 over 4a. And then you do your termination indicator after that.
Oh, that was wrong. Okay.
Miss.
Oh, yeah.
Can
Okay.
I just take a guess at this one?
Hold on, Justin, does that help?
Yeah, it looks a lot neater than what I was trying to do.
Okay. All right, so now, remember we're talking about fifth roots. And before we multiply the denominator by something we would know is a perfect square. So in the denominator we have 4a. And we want a base, so we want a number that has a base root that can be raised to the fifth power and get that number. Is there a number we can multiply 4 by that we know we can take the fifth root of?
20.
That 4 times 5 is 20, but we want a number that it's something times something times something times something times something that'll give us a number that we can multiply, that 4 is a factor of. That's what I'm trying to say.
100?
You see 100?
100.
And I don't think 100 is going to work. So let's try the smallest number. So let's try 2. What is the fifth root of 2? 2 times 2 times 2 times 2 times 2. What is that?
32.
32. Okay, now, so that equals 32. So that's 2 to the fifth power. So we know the base is good because it's a base, but we know the power is correct. But is 4 a factor of that number?
Yes.
Yeah, what do we need to multiply 4 by to get a 32?
8.
8. Okay. So now we know 4 times 8 equals 32. That's good. Now let's look at this a. How can we get a raised up so as a to the fifth power? What do we need to multiply that a by to get it to the fifth power?
You would want to times that a by a to the fourth.
Correct, a to the fourth. So what I want everybody to do is, let's look at this. So remember, we have to put it under the radical sign. So now we want to multiply the numerator and the denominator by another fifth root. And we have all agreed that the 4 times 8 gives us a number that has a base to the fifth power. So we said 8, and we said a to the fourth. Okay, so if we multiply our numerator and denominator by the fifth root of a to the fourth, let's see what happens. Okay, I'm going to move my thing down further so we have more room. So what happens to our numerator?
It becomes 40a to the fourth.
To the, yes, 40a to the fourth. And what about our denominator?
It turns to 5 radical 32a to the fifth.
A to the fifth. Does everybody agree with that? Is everybody up to speed on that? Or do we need to backtrack at all before we move forward?
Backtrack.
Okay, what do we need to backtrack on?
I don't know. It doesn't make sense to me yet.
Okay, so let's finish up this one, and it might start to make sense to you after we finish this one out. And then I think I know where this confusion is, and so we'll practice a little bit. Okay, so now we have this new fraction, 5th root of 40a to the 4th over 5th root of 32a to the 5th. Now we can't leave that radical in the denominator. So what happens when we take the 5th root of each piece?
You did 8a to the second, I think.
Okay, you're on the right track. Okay, so what is the 5th root of 32? What number multiplied 5 times together gives us 32?
2.
2. So when we do the 5th root of 32, it just becomes a 2. And now we need to take the 5th root of a to the 5th.
A.
A, right, because it's asking us how many groups of 5a's do we have? Well, we have 1. So then our final answer, our final simplification, is a numerator of 5th root of 40a to the 4th over 2a. And what we did by doing that was we got rid of any radicals in the denominator. Okay, so I want to practice something. I want to just do a couple of things really quick. So I just want to do some rationalization. So if I have the square root of 3 x to the third, okay, 3x to the third. Now we can't take the square root of it, but what can we multiply this by in order to take the square root of it and get rid of the square root sign? So we're asking ourselves, what can we multiply this by to make this a perfect square under the radical sign?
You could.
Times it by 3.
Yeah, we can do, so square root of 3, and what can we do with this x to the third? How do we make that something that's a perfect square?
3x to the ninth.
We don't even need
3x to the third.
We don't even need to do that. We can just do 3x. Because
But wouldn't that make it 3x to the fourth then?
Yep, and then you can take
I
this.
see what you're getting at now.
Yeah, so because we can take the square root of that. So remember, when we're multiplying our radicals, you have radical sign and then you multiply the radicands together. So we have 3 times 3 is 9, and then x cubed times x is x to the 4th. And what is the square root of 9x to the 4th?
3x squared.
Does everybody see that? Understand how I got that?
Yeah.
Okay, so now I'm going to give you another one. So I have to come up with one. Okay, let me whip out some math skills real quick. Well, give me just 2 seconds. Okay, so what we have is the square root of 6 y to the 7th. What can we multiply this by? What radical or square root can we multiply it by so we can make it a perfect square so we can take a square root of it? So what number can we multiply 6 to make it a perfect square?
6.
6. Times square root of 6. And how about this y to the 7th? Basically, we need to make it an even number.
You want another 7?
We can do y to the 7th, or we can even simplify it even more. We can just multiply it by y, right? Because that would give us to the 8th.
Yes.
Okay. So now we have the square root of 6y to the 7th times the square root of 6y. And when we multiply those together, what do we get?
Wouldn't that equal 36y to the 8th, which can be simplified to 6y to the, I would like to say 4th.
Yes. Okay. So now, Kasia, is that starting to make sense?
No.
No. Okay. So let's see here. So do you understand the concept of what we're trying to do?
Not really.
Okay, so what we're trying to do is basically, so you know things that are perfect squares. So we have 4, 9, 16, 25, 36, 49. What's the next one? 64. And then 81. And then 100. For example, right?
Yeah.
So if you have the square root of these, you get a nice pretty number, right? You get 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. And we know with fractions, whatever we do to the numerator, we have to do to the denominator, and it doesn't change it. So, I mean, just like 3/4 is the same thing as 6/8, is the same thing as 8/12, and so on and so on. Or 9/12, sorry. So we're trying to change our denominator into something we can take the square root of, so we can get rid of that pesky radical sign. Okay? So we are multiplying our denominator numerator by, in this case, we're just multiplying a number, figuring out how we make it a perfect square. What number can we multiply it by to make it a perfect square? So that's what we're trying to do. So like the last one, we multiplied it by a square root of 6y, because then the radicand becomes perfect squares. And then we can take the square root of it, and it gets rid of the radical sign. Okay, so the whole purpose is just getting rid of that radical sign. Okay, so let's see here. Well, let's just try something. So we have, all right, okay. So we have the square, we have to have a pen, square root of two AB squared times the square root of 6A cubed B squared. Now on this one, all I want you guys to do is just multiply those together. So just multiply these guys together and see what happens. And then once you've done that, let me know what you get. Because remember, you multiply like terms under the radical, so then you get one radicand.
Can you repeat it?
Oh, yes. Oh, hold on. Okay, so we have square root of 2AB squared times the square root of 6A cubed B cubed. So you get 12 a to the 4th b to the 4th. Exactly. Now, the next step to do for this is to look and see what we can pull out of here, because we have some perfect squares in here, don't we?
Yeah.
How about this 12?
It's not perfect.
Yeah.
Are there any perfect squares that live inside of it?
A squared, B squared.
In 12, can we break down 12?
Oh.
Is there factors of 12?
3, 4, and 6.
Okay, now, are any of those a perfect square?
4.
Yeah, so we can rewrite this as the square root of 3 times 4 a to the 4th, b to the 4th. So this is the exact opposite of what we were just doing. Now let's pull out of this. Let's pull out of.
My bell just rang. I have to go.
Okay.
All right. See ya.
See ya on Monday.
Yep.
Okay. So I want you guys. We're gonna stop here, but I want you guys to work through this one and send me. Just throw up on Yammer. Just throw up on Yammer what you guys think we could do to simplify this.
Miss Wolf,
Just for Monday. Yes.
would you put the problem up on Yammer?
I certainly will. I'm going to put it up there, and then you guys can throw up your. I might even do it as a poll.
Okay.